All right, welcome everybody. This is the solution discussion section of today's contest. Today we managed to do 3 questions and we almost got the last one, so we're going to go through them one by one, starting with question number 1. So, question number 1. Smallest missing integer greater than prefix sum. I think from the chat that the biggest problem with this is understanding what the heck this question is asking for. Okay, so let's go through that. Let's make sure we understand what the question is asking for. So it says here, prefix nums 0 to I is sequential if for all indices, j between 1 and I, nums j equals to nums j minus 1 plus 1. So what this means is that you want to see an ascending sequence. You ignore 0, so j starts from 1, not 0. Okay, so the first number is always valid, whatever it is. And then the second number must be 1 more than the first. The third number must be 1 more than the second. Okay, this is what this means. Start from the basically index 1. So ignore the index 0 and ignore first number. And you want to keep going until you break the sequence. So the sequence here is 1, 2, and 3. Okay, the sequence here, the sequence that is what do you call it? Sequential prefix. The sequential prefix here is 1, 2, and 3. So it's prefix which means it always start from first one, and it keeps going until it breaks the pattern. So same thing, sequential prefix is 3, 4, 5. Next one is 1. 1 break. If it's 6, it'll keep going, but because it's 1, it stops. All right. So this is the thing that we have to do. So first thing we want to do is to find the sequential prefix. We're going to sum up the sequential prefix, and then we want to find the sum of the first number x smaller, larger or equal to the sum of sequential prefix that is small, that is not in a list. Okay, this is not words, right? A lot of words. What this basically means is that 2 parts to your problem. 1, find the sequential prefix. Yep. So what you want to do is, well, you want some kind of loop, right? You want some kind of for loop. You start with the prefix sum. Prefix sum is equals to nums 0. So nums 0 is always a legal part of this sequential prefix. And then you keep going. You do a for loop. It starts from 1, not 0. And keep going until the end. And you say, okay, if this nums I should use j because that's the symbol that they use on top, right? If nums j equals to j minus 1 plus 1, so if this is increasing 1 more, then we keep going. If not, break, right? So what happens when we break? When we break here at this break, we basically have prefix sum equals to sum of whatever's in the red bar. Okay? We have the sum of the red bar. And then what we do next is we find smallest int greater equal to prefix sum that is not in list. This is a lot of words. This is a lot of fairly convoluted. But what it essentially says is you start from prefix sum. While it's in nums, you do plus plus until you break, which means you get j, which is the first number larger than the prefix sum that is not in nums. Okay? So any questions about this for people who needed it? Abhishek and Flutter? We don't have to search for the entire array, instead from where the sequence is break. Yeah. Yep, that is true. I have to use the number above. Yeah, I regret using a to io, like I plus 1. Yeah, sure. It's not such a big deal, I think, because the size of the array is fairly small. So you're not going to run out of bounds either way. But that is actually a very good point, Aniket. Okay, with that, let's go to question number 2. If you have questions, spam in the chat. If not, I'm going to go on. Okay, so question number 2, I personally found it really annoying. But let's start with the question and see what it says first. It says here, you're given a 0 index integer, nums, and a positive integer, k. You can apply the following operations on array number any number of times. Choose any element of the array and flip a bit in its binary representation. Flipping a bit means changing to 1 or 0. Okay, you're going to convert all the numbers to binary, and then you're going to flip bits. Return the minimum number of operations needed to make the bitwise XOR of all elements of the final array equals to k. This sounds... Okay, so let's see what that means in practice, okay? So let's say your nums is 2, 1, 3, 4. So 2 is 1, 0. 3 is 1, 1. Oh, sorry. 1. So 2, 1, 3, and 4, right? Okay, so this is all the binary representation of 2, 1, 3, and 4. So you're going to do a XOR of these guys. So XOR of this is going to be 0. XOR of this is 0. XOR of this is 1. It's exclusive OR. Exclusive OR basically means you count how many bits there are, and then if it's an even number of bits, that's going to be 0, or 0 bits, that's 0. If it's an odd number of bits, it's going to be 1. So this odd number of bits is 1. You count the number of ones, essentially. Alright, and so you want to get output 2. So what is output 2? Output 2 is you want to get from here to 0, 1, 0. So what you do is you want to flip each bit, right? So it says here, choose element 2, which is 3. You want to flip this guy. Let's choose a different color. Choose element 2, which is 3. And then you want to flip the first bit. So you're flipping this bit. You change this 1, 0 to 1. Okay? Well, what this does is that now this one becomes 0. Because you get a 1, 1, 1. You have now even number of. And then you have 0, 0, 0. And now you choose element 0 and then flip the third bit. Oh, sorry, k is equals to 1. So your job is to reach k is 0, 0, 1. So now you choose element 0, you flip the third bit, you change this to 1. So you have 1, 1, 1, 1, and 1. That makes this 1. Okay, so you get 0, 0, 1. So that's what you're trying to do. Now the thing that annoys me a little bit is that there's actually like a small trick, which yes, thanks for Arkham for pointing it out. Essentially, what you want to realize is that it doesn't matter which number you choose. It doesn't matter which number you choose. If you flip a bit in that position, it's going to change the output to a new thing, right? It doesn't matter if you flip this bit or you flip this bit or you flip this bit. It doesn't matter, right? All it matters is how many bits you need to flip for each position. Okay? So with that, what you really need to do, what that means is basically you have to start. How do I get rid of all the blues? Okay. So essentially what you need to do is first you have to XOR everything up. You get 1, 0, 0, right? Let me see if we can erase it a little bit. 0, 1, 0. 0, 0, 1, 0, 1, 1, 0, 1. You want to XOR everything up, you get 1, 0, 0. Okay? So now, because for each bit, it doesn't matter who you flip. You just flip anybody, right? Anybody you flip, you'll change it. So all you have to do is to XOR everybody up, get this, and then count how many bits you need to flip. How many bits, essentially how many bits are different. So this is different. Yes, you flip this. This is different. So you have to flip 2 bits. And which number do you flip? Doesn't matter, right? Just flip the first bit and the third bit in any 2 numbers. So this is my code. Essentially what I do is I take k-string, I convert it to a binary format. I take XOR, and this is the first step. XOR everybody. So this is what I'm doing here. XOR everybody. Okay? And convert it to a string. So I XOR everybody and convert it to a binary string. And then now, count how many bits are different between k and the XOR of everybody. I can't spell. So this is what is happening. So that's you do a little bit of trickiness here. You have to pad. You have to pad them to make them the same length. You have to add zeros in front. You don't actually have to add zeros in front, or maybe you do. I don't know. But I just did it this way because it was easiest. And then what you do is you don't need this print. You do for I in range length k string. So this is basically, this part is pad them to make them the same length. Go through the 2 strings to count how many bits need to be flipped. Yep. So that's basically it. That's an easy question. Yes. So outcome exactly, that is exactly right. XOR it to k. Hey, you know what? Your solution is better than mine. So XOR the last one to k and then count the ones. Yes. I forgot about that. My bitwise operation is not that great. So Aniket, hey Alex, could you some resource where I can improve my problem solving skills? And thanks so much for today's help. No problem. Problem solving skills. Problem solving skills. I think of problem solving skills as there's 3 types of problem solving skills. The way I think about it, right? There's one is your programming fundamentals. Given an algorithm, if you already have the algorithm in your head, somebody explain in English what algorithm is. Can you translate the algorithm to words? That's the first step. That turn a fixed algorithm that you have in your head to words. Okay? That one I think is practice. Practice with easy problems. Don't practice the hard ones. Practice the easy ones. Practice building bigger and bigger projects. So that is actually, to me, the most important skill. And practice a lot of programming. The second skill about problem solving is your fundamentals, your data structures and algorithms. So know your dynamic programming comes a lot like 2-pointer solution. If you're interested in LeetCode, if you're interested in real world programming, which I want to do more of in my live streams, writing more complex problems will help you. Right? My recommendation is pick data structures that you know really well, like trees, like lists, like heaps, dictionaries, and implement them yourself. So you know how the dictionary works, implement your own dictionary class. You know how heap sort work, implement your own heap sort or your own red black tree or whatever cool stuff you want to do. So that's the second level. Okay, those 2 I think are really important to get right because those 2 makes you a better programmer. And then there's the third level, which is problem solving specifically for competitive programming problems like LeetCode. So the third level is being smart, being clever and seeing tricks. So this one I actually don't recommend you spend too much time on it because it's useful. Knowing the tricks are good for solving LeetCode. I'm the best. That's fine, right? I'm going to tell you that the best programmers in the world are terrible at the third level. It doesn't matter. Right? The first 2 levels are super important. Those are the ones that make you a better software engineer. Those are the ones that make you better at writing large software. You want to hack something up on a weekend project. Those things make you better. The third one, knowing the trick, knowing those math, those are really only important if you're doing something really, really advanced in real life, which usually you won't. And even if you're like an ML engineer, you won't use that very often. And I can tell you that because I worked on ML at Google before. That was my previous job for about 10 years. So even as an ML engineer at Google, I hardly use those kind of advanced algorithms, right? The first two, get your foundation right. The third one, if you really want, do more LeetCode, is my suggestion. And just practice. Yep. So path, yes, exactly. Yes. So that's you got an even better answer than me. So path and outcome. Yeah. And the other thing about competitive programming is that sometimes you don't look for the best answer. You don't look for the fastest answer or the most, well-written answer. You want to write the answer quickly. So that's something that I'm not very fond of in competitive programming. But that is what it is. Okay, so question 3. Minimum number of operations to make x, y equal. So you're given two positive integers, x and y. In one operation, you can do one of the following. You can divide by 11 if x is multiple of 11. You divide by 5 if x is multiple of 5. Decrement x by 1 or increment x by 1. Wow, this is a lot of things, right? So you think about it, the clearest way to do this. First of all, when I read questions like this, I like to think about what are the edge cases first. It's funny, my brain straight away goes there. My first question is it possible? No, I'm not working at Google anymore. So the first. Okay, let me see. What was I gonna say? Yeah, the first thing I think of is actually, is there a case where is there a way where I can get no answer? Is there x and y such that no matter how many operations I run, I never get from x to y? Well, it turns out there isn't. Because we know if x is smaller than y, you just add 1 to it. You keep adding 1, eventually you reach y. If y is smaller than x, right, then you just minus 1. You keep minusing 1. Eventually you reach y also. So eventually you'll make the two equal. So there is never a case when there's no solution. Obviously, this is not going to be the minimum number of operations. That's not the answer. But instead, that we at least we know that definitely we'll reach the solution somehow. So the way to think about this is, well, you have 4 operations, right? So let's try to explore the space. Somebody in the chat said a word that I really like. I really like this word. BFS. A breadth first search. If you're not familiar with breadth first search, definitely take a look at it. If you are interested, write in the chat, write in the chat. If you want me to release a video just on explaining, very simple explanation of breadth first search, like 10-minute, 5-minute video, write in the chat. I will make something like that. That's also possible. So breadth first search, what that means is, let's start from x, okay? Let's say x is 26. And then y equals to 1, right? X equals 26. Well, we're going to do a breadth first search, and we're going to say, what are the 4 things we can do here? 1 is we can add 1. We can minus 1. We can divide 11. Or we can divide 5, right? Those are 4 possible operations. Plus 1, yeah, sure, let's just plus 1. That's cool. We can get 27. Minus 1, we're going to get 25. Divide by 11, well, that's not going to work because it's not divisible. Likewise, divide by 5 is not possible. Okay? So from 26, in one step, we can get to 27 and 25. We're going to get 1. We don't know how to get to 1 yet. Okay? And then now we keep searching. We say 27, what are the, let's start with 25 first. 25, what are the 4 possible operations? Well, again, there are 4 possibilities. First, you minus 1, you get 24. You can plus 1, you get 26. And then you can divide by 11. That's not going to work. And you can divide by 5. Right? Divide by 5 works. This gives you 5. Because we know that 25 is divisible by 5. How I get the approach is asking. Okay. Right? Okay. Now, and then you keep expanding the tree, right? Everyone will have 4 branches. Everybody, if it's not an X, you'll have 4 branches. You have 4 branches. You have 4 branches. So this is the essence of the tree, right? This is the essence of your BFS. You're doing a breadth first search because it's breadth first because you go over this guy and then you go over these guys, and then you go next level all these guys. That's why it's breadth first. Now you'll notice something, however. Two things you'll notice. One is you'll notice the tree becomes extremely large if you just do the breadth first search naively. You do like a recursive solution, right? You do a recursive solution. For those of you who tried with the base case, oh my god, it is so big. In fact, there's no base case because you can always add 1 or you can always subtract 1. There is no base case. Your recursion is infinite. Damn. What are you gonna do? Well, the second observation is you actually repeat some numbers. Look at this. Look at this. You start from 26, right? You have checked 26 already. At some point, you minus 1, you get 25, and plus 1, you get 26 again. Right? So you've checked 26 already. You shouldn't check 26 again. You want to check 26 only once. So that actually is your base case. That's your base case right there. You want to check, want a list of numbers. You want to maintain a list of numbers that you've already checked. If you've checked that guy before, don't check him again. Right? Same thing. You think about this 24. 24 minus 1, 23, and then minus 1, 22, and it keeps going. You keep minusing 1. In theory, you can end up at 5. Right? But 5 is also here. So there's 5. There is 5. And then there's 5. So you want to say this one? No. Why do you pick this one? Because this one is deeper down. You want to do the ones at the top first. This guy is further up. So you want to do him. Yeah? So this brings us essentially to the essence of, ain't it like the backtracking? Let me make sure I get all the chat messages. Approach. Yeah, this brings us to our approach. But let me answer some chat questions first. How I get the approach? Asking the minimum. Shortest path, and then the shortest path use DFS. Yeah. So don't use DFS. Use a breadth first search. Breadth first search. It's shortest. You want to get from X to Y, right? But you want the shortest path, not just any path. If you just use depth first search, you explore you go down a rabbit hole. You go down and down, like it's going to go on forever and ever. You're going to be sad about it, right? So instead, what you want to do is you want to use a breadth first search. First, check everybody who is 1 step away from X. Next, check everybody that's 2 steps away from X. And then check everybody that's 3 steps away from X. And so on and so forth. Okay? So that's essentially breadth first search. Okay. So I'm going to go through my program. I don't think it's the prettiest. But you know, there's some time limit, so I just wrote whatever I can write quickly. So the way I did it is I actually didn't want to use recursion. In general, you know, when you're using recursion, you have to be a little bit scared because there is this thing known as the max recursion depth. And in Python, the max recursion depth, if I believe, is 10,000. Max recursion depth 1,000. Okay, that's not great. Which means if your recursion is too deep, if this recursion is too deep, right? If it takes like a lot of steps, then it's gonna fail. So I generally, like, because you know there's a time limit, I don't want to think too much about it. I generally don't use recursion. Instead, I do this thing known as a work queue. So I have a work queue. DFS, you use a queue. Yeah, you basically have a queue, and then you append to the queue. So the way to do it is like this. First, I define a thing called memo. This is my memoization table. It's up to 10,000 because I know that x and y is up to 10,000. Okay. Yeah, I don't know if that is. Yeah, hindsight, I'm not sure if that's that's actually true. But let me think about it a little bit. But it passed the test case. But in essence, you have to create a memo table. So the memo table is used to keep track of what the numbers we've already seen, right? Like here, we've already seen 26. So we don't want to explore 26 anymore. When we explore this 26 here, we want to put it in the memo table so that later, when we see another 26, we're going to say, aha, it's already in the memo table. I don't want to explore it anymore. Okay? So this is how we do it. A lot of you guys said dynamic programming. This is basically dynamic programming. Sort of. Depends on how you define dynamic programming. But, that's all semantics. So basically, I have a queue, a work queue. This is what else needs to be done. I append x. I start with x. So the memo of x is 0. I take 0 steps to reach x. Okay? And while the work queue is not empty, I'm going to pop the next item. So at the beginning, x, the work queue equals to x. Let's say it equals to 26. Okay? You can use the visitor set too. Like I said, I don't know if this is the most prettiest solution. It's just the one that I came most quickly to me, so I just wrote it down. I actually got stuck because I had a bug in this. I think one of the signs here I flipped, and I couldn't find out what the problem was. I was stuck here for 20 minutes. Okay, so you want to pop the next item, and then what you want to do is you want to try the 4 different steps. Okay, if next is smaller than the length of ammo, then I can add 1 to it. If it's larger than 0, I try -1. If it's already 0, don't try -1, right? If it's divisible by 5, then try divide by 5. If divisible by 11, try divide by 11. And at every step, what I do is I basically do this. Right? If memo idx equals -1, means I've not seen it before. Or if memo, I actually don't need this. I just check if memo idx is -1. Memo idx equals to rec. So required is basically the current, so next, plus 1. So how many steps I need to take to get to this next? Well, I'm going to try 4 steps, right? So this is 1 more step, so I need to add 1 to it. So rec is memo idx plus 1, and then I add to idx to work queue. So for 26, I'm going to say my memo 26 will be 0. And then I'm going to take out 26. I'm going to add 25, 27, and then 25 will be 1. 27 will be 1, right? And then I take out 25, and then I'm going to say, 25, I can add 26. Well, that's already seen. Nope. So 24. So 24 is going to be 2. Because it comes from 25, 1 plus 1 is 2. Or I can go to 5, also 2. So this memo keeps track of what's the best way of reaching each number. And when one of these numbers is y, it means that you're done. So one thing to note about memo is that if you do it breadth first search, then you have a very good advantage, which means you minimize the number of steps you take, right? You do everybody with 1 step first. So notice, yeah. You can use a visitor set also. So notice my queue start at 26. After 26, I add 25 and 27, right? And then I take out 25. I'm going to add 24 and 5. Now the important thing to note is that these things are added at the end. They are added to the end after 27. Because 27 only takes 2 steps, where these guys take 3 steps. So I want to add them afterwards. Okay? So that part is fairly important. So the solution looks a bit like this. Is DP as you guys have said. You do the 4 steps and keep going until you reach next equals to y, you return memo y. So I'm pretty sure, I'm pretty damn sure this will never happen. But I just added it for fun. Okay, so this will work. So if you just do the BFS without the visited check, then you will run into an infinite loop. Okay, cool. Think about shortest path, yeah. Okay, cool. And by the way, I just want to say, by the way, thanks a lot for the people who are active in chat, especially the people who don't just ask for solutions, but actually contribute, right? So people who ask questions, people who, help your fellow friends. This is where we're all here. We're here to learn. And learn we must, because when it comes to question 4, I have to tell you, I didn't manage to finish it. I managed to get most of it done. But I ended up with what do you call it? I ended up with time limit exceeded. Okay, but I'm gonna explain what I have so far. So question 4 is like this. There are 3 integers: start, finish, and limit. You're also given a thing s. A positive integer x is powerful if it ends with s, and each digit in x is at most limit. So this is 2 constraints, right? 2 constraints. Total number of powerful integers in the range start to finish. There are 2 constraints here. So take for instance, let's pick a nice example, not a degen example. So let's say 4 and 6,000. Okay, and s, let's say this example. Oh, whoops. So start is 1. Fin is 6,000. And limit is 4. Okay? What are the powerful integers here? Well, the first powerful integer is 124. And then there is 1124. That's the next powerful integer. Wait, is 1024 not a powerful integer? Oh, yeah. So 124. Yeah, correct. So 2124. 3124. 5124. 4. Oh, oops. I messed it up. 4124. Okay? And you can't go to, there's no 5124. Because 5 is larger than limit. So basically, you have to take the numbers at the back, a constant, and then the numbers in front, you have to make sure none of them exceed limit. Okay? So the way I think about it, there's a few ways, right? So the most obvious way, and also the way I guarantee you will not work, is if you do a for loop from start to finish, you do a for loop, and for every single number you check, does it fulfill these 2 conditions? I'm going to tell you that is not going to work. That is not going to work, because the number of numbers here from 1 to 6,000 is 6,000. If you look at the size of finish, it's 10 to the power 15. You do a for loop from 10 from 1 to 10 to the power 15. Yeah, things will not end well for you. 10 to the power 15 is a very freaking big number. Okay, so instead what we want to do is we want to count this. We want to jump a little bit and count this. So yeah, I know somebody, I think it's like Code Forces, Code Crew, managed to do 4, right? And if Code Crew wants, feel free to share your answer, your strategy in the chat. I will say what my strategy was. I didn't manage to get to the end, but I think I'm pretty close. Okay, here's my strategy. Here's my strategy. My strategy is as follows. I'm going to segment this problem into 3 parts. Let me erase this first. Okay, I'm going to segment this into 3 parts. And let's say I change the problem a little bit. I'm going to segment this into 250. Okay? I'm going to segment this into 3 parts. Part 1, Part 2, and Part 3. So Part 1 goes from start to, I'm going to find out how many digits this is, right? Because all my answers, the last n digits are the same, right? So I'm going to call this like s length of s equals to 3, right? So the last 3 digits, since s is 124, the last 3 digits are always the same. So what I'm going to do is I'm going to find the smallest number larger than start, whose last 3 digits are 0. So this is 1000. And I'm going to do the same for fin. I'm going to find the largest number smaller than fin, whose last 3 digits are 0. So this is 6000. Okay? So I'm going to think of the problem in 3 steps. Step 1, from 1 to 1000. Step 2, from 6000 to 6250, which is fin. And then step 3 is everything in the middle. Okay? So it turns out that step 1 and step 2, these two ends are pretty easy. Right? If 6000 is the largest number where all 3 digits are 0, that's smaller than fin, then there's only one possible answer. There's only one number that matches this. All I have to do is to check this. I have to check this. Right? I have to check this to see if this is valid. There's only one number between this 6000 and 6250 who ends with 124. So I just have to check this guy. So same thing, I just have to check 124 because there's only one number between start and 1000 who ends with 124. Okay? So I have to check these two. And if they're legal meaning the limit is 4 or less, then I'm going to say yes. Okay? This is the first part. Second part is I want to count from 1000 to 6000 how many numbers there are that end with 124 and where the first digits are all smaller, or the first whatever digits are all smaller than 4. Okay? So this becomes you can actually eliminate. So this is where we eliminate 124 from the equation, because essentially what we want to do here, you're going to count how many numbers from 1 to 60. Oh, sorry, from so because the last 3 digits are fixed, right? I can ignore the last 3 digits. In step 2, this in-between part, I'm going to ignore the last 3 digits. All I have to do is to count from I'm going to just divide by 1000, right? I get 1 and I get 6. So I count from 1 to 6. How many numbers there are from 1 to 6 whose what do you call that? Whose digits are all smaller than limit. Okay? So this is the third thing we need to do. So step 1. So as a recap, step 1, step 2, and then step 3. How many numbers are there between 1 to 6? Just this barrier here and this barrier here. You just divide by 1000 or whatever the length of S is. And I want to count how many of them have digits less than limit. Okay? So this is where I got. Okay? I'm going to show you my code. So I wrote some helper functions, round up, round down. So round down to places is, you know, 1. 1, that means round up to the nearest 1, the nearest 10. Places 2, round up to nearest 100, and so on and so forth. So this is round up, round down to a nearest power of 10. And then legal checks, you know, is this if everything is less than limit. Okay? So these are the 3 helper functions that we have. So this is what I have to do. So I'm going to first define this thing called new start. New start. Right? New start is this thing here. And then new finish is this thing here. So I have new start and new finish. I define those. So new start is basically new start is round down, round down start plus int s. New start is actually is this one. Actually, new start is this one, and then new finish is this one. And I also check if their new start is larger than start, and legal. And new start is smaller than finish, and then new finish, legal, blah blah blah. So this is what I do to check that these 2 numbers are okay. So if these 2 numbers are okay, I'm going to add them to count. So count equals 1 plus 1, count equals 1 plus 1. Okay? So the next thing I need to do is this. From start up to finish down. Okay, so start up is this 1000 here, and finish down is this 6000 here. This is a round up of start and round down of finish. So from start up to finish down, so what I did is this. This is the primitive way. For n in range, start up, divide by 10. So in that example above, right? Start up will be 1000, and then finish down will be 6000. Okay? In the example here, start up will be 1000 and finish down is 6000. So I've checked everything before. I've checked everything smaller than 1000 and everything larger than 6000 already. That's new start and new finish. So all I have to do is to check between 1000 and 6000. So I'm going to remove the last 3 digits because last 3 digits are always 124. So I just count from 1 to 6. How many numbers are there from 1 to 6? That all their integers or all their digits are less than limit. So n is essentially goes from 1 to 6. It counts if n is smaller than limit, count equals count plus 1. Okay? So when I run this code, this actually works for, I believe, I hope I'm not going to be embarrassed. Start up to finish down, line 42. Oh, whoops. I believe Yeah, no, I'm not. I used to work at Google, not anymore. Now I'm actually I teach at a university, so I'm an adjunct professor at a university in Tennessee. Which means a lot of my students are just like you. I teach freshman computer science, and a lot of students are just like you. And actually, a lot of my students are even more beginner than you guys. So don't be ashamed that you're stuck at problem 1. The fact that you are on LeetCode, you're trying to make yourself better is already a great thing. So I ran to time limit exceeded. I'm going to see if this allows me. Okay, so I solved 257 out of 931. Right? So I actually, let me see. Actually, actually solved a number of correct. So this tells me, because this is a fairly large number, this tells me that probably my algorithm is right. My sort of general strategy, my general thinking is correct. But I'm not fast enough. That's the part that I need to fix. Okay? So the part I need to fix is getting faster. So how do I get faster? Well, the main way to get faster is this part in the middle. This from 1 to 6. I haven't finished this, but I believe that this is the right way to do it. So instead of going from, every number from 1 to whatever, I'm going to do the thing where I count how many numbers are there from 0 to 6,000. I'm going to count how many numbers are there from 0 to 1,000 that 0 to 6 or whatever that obey this law. Okay? And then I'm going to subtract them. So essentially what I want to do, okay, I kind of like this. Can't save this. Save drawing. Oh, sweet. It saves drawing. Okay, cool. So I have the drawing. I'm going to save it. Okay, cool. So I have that. I'm going to erase this. So now I'm going to make the problem. The problem is a bit easier, right? Okay, let's see what's the one I got stuck at. The one I got stuck at is here. So essentially, now my start up, if you look at this, it's going to be, because this is 26, right? Meaning I'm going to have the first number where the last 2 digits are 0. So my start up is 1200. And then my finish down equals to 18648545500. Okay, because 26 is a 2-digit number, my last 2 digits are going to be 0. I'm going to count how many numbers there are from start up to finish down. How many numbers there are whose digits, who all their digits are less than 7 or 7 or less. So the way I originally did it is just go from 12. Yeah, I can just like delete. I just delete like the last 2 digits because they're all 26. I'm going to go from 12 to 186485545, and I'm going to count how many digits there are. This turned out to be very slow, so I want to have a better way to count this. And I think the better way is I want to count how many numbers there are in here whose digits are more than 26. And this would be, okay, let's pick a simple example. Let's say I want to pick 1864, right? I want to count how many numbers are there whose limit is 7. Well, this is basically 1000 plus 800 plus 60 plus 4. So for 4, the answer is 0 because 4 is more than 7. So for 60, the answer is actually what do you call that? n, which is 7 times. So because 6 is larger than 7, right? So we get 7 times 5 plus 6. Sorry, 6 is smaller than 7. So it's 7 times 5 plus 6. I have to think about the math for a while. I'm thinking about the math, right? It's going to be, basically it's going to be 7, 17, 27. Yeah, it's going to be 0 to 7 plus 10 to 17 plus 20 to 27. So that's why it's 7 times 5 all the way. Is actually 7 times 6, I think. So because it starts from 0 plus, this is basically up to 50 and then plus 6. Yeah, so I have to think about this for a while. I think about this for a little while. Actually, I think 6 is not. Anyway, I'll think about it for a little while. So I think this is the right way to do it. So essentially, because there should be some trick to optimize this, right? To count how many numbers are there from 0 to this whose digits are smaller than 7. There's some mathematical trick. But either way, let me think about it for a while. I might release a new video, or I might talk about it next time. I think for this question, I managed to do most of it, except, yeah, I managed to do some of it, not most of it. I managed to get the correct answer, but it's too slow. So that's where we're at, basically. And so that's all 4 questions. I hope this was helpful. Before I go, I want to say something about questions 1, 2, 3, and 4. Because somebody asked. Now, if your goal is to become better at competitive programming, then it's really important to solve all 4 questions. But if your goal is to become a better software engineer, then I think you need to get to a point where you can solve 1, 2, and most of 3 reliably. Because 1, 2, 3, 1 and 2 is just basic fundamental software engineering. Those you should get. 3, sometimes there's a trick. Sometimes there's sometimes you need the right data structure, like you need a memorization table. You need these standard data structures and algorithms to help you. 4 usually is something like really, really weird and crazy. So if you don't get 4, it's fine. It doesn't mean you're a bad engineer, right? It doesn't make you a bad programmer. It means you're bad at competitive programming, if bad at playing the LeetCode game. But if you're trying to interview, if you guys are trying to get tech jobs and you're going to go for tech interviews, you should make sure that all the question 1 and question 2, all the LeetCode mediums you get, right? Don't worry about hard. The hard are, for people who like competitive programming, who like LeetCode style questions, right? That's not going to help you all that much. So if you guys want more content around building software or different kinds of data structures and algorithm concepts, let me know in the chat. I will be moving to more real software. I'm going to try and build real software. The next time we see each other, I'm going to try and build a Chrome plugin. Remember to like and subscribe. I really appreciate all of you for hanging out. And thanks a lot, and goodbye.